Hey everyone, here's another problem from the homework in section 11.9, and this was number 5. So it says evaluate the indefinite integral as a power series. So when you look at this, right, it's not asking you to actually evaluate the integral as it is. We want you to use a power series in order to evaluate it. So the question is which power series? And so again, we should look at the function and try to build from a known power series. So what are some of the known power series? So you can look them up in your book, but the one for this section that we've kind of been working with a lot is the 1 over 1 minus x, 1 over 1 plus x. Those are the two that we've been working quite a bit with in this section. So 1 over 1 minus x, right, that is our standard geometric series. So this is n equals 0 to infinity of not negative 1, I'm thinking of the next one, of just x to the n, your standard power series, geometric series. And this is the alternating one. All right, so here, notice that because I have the minus there, I'm going to use then this power series. So we're going to use the top one. But, so let's build on this. So this integral means that I have t times 1 over 1 minus t cubed dt. Right, and the reason that I write it like this is because I want to be able to match my function with the power series. So this has a 1 on top of it, so I want to make sure that I have a 1 there. So I just factored the t out, put it on the side. That's a times. And now, right, I have my t cube. So what do I do with this? Well, in place of x, I have t cubed. So I'm going to substitute my t cubed for every x that I see in that geometric series. So therefore, we can say just 1 over 1 minus t cubed will be the power series for the one that's up here, right? But with every x being a t cubed. So it's going to be 1 plus t cubed squared, and so on, plus t cubed to the n, and this keeps going forever. So we can say 1 over 1 minus t to the third is really the summation from n equals 0 to infinity of what is that going to be? T to the 3n, right? So then that's just 1 over t cubed. So what is t times 1 over t cubed? 1 minus t cubed. So then this will be t times the summation n equals 0 to infinity of t to the 3n. Right, but bring that t in there, so I get the summation n equals 0 to infinity of t to the 3n plus 1. And so that is our power series for this function. So now that we have the power series, we can evaluate our integral. So let's go back to the integral. We were trying to find the indefinite integral of t over 1 minus t cubed using power series. So that means that this is really the integral of our power series, which is the summation from n equals 0 to infinity of t to the 3n plus 1. And I can, properties of summations allow me to flip-flop those two, so it's really the integral of t to the 3n plus 1 dt, and do the integral of that. So I'm going to have n equals 0 to infinity of, what is that? T to the 3n plus 1, but we're taking the antiderivative, so we add 1, so it'll be plus 1, which is 2, divided by the new power, 3n plus 2. But I am taking the integral, so I'm going to get plus a constant. So this would be our antiderivative as a power series. So the antiderivative t over 1 minus t cubed dt has a power series of n equals 0 to infinity of t to the 3n plus 2 over 3n plus 2 plus a constant. All right, so that's how you use power series to find also indefinite integrals.